Hello and welcome in the IBP series powered by Camelot. Today, part 1 of the optimization. There will be several episodes to describe and present the optimization capabilities provided in SAP IBP. Because we want to present a global view, a holistic view of the optimization capabilities in SAP IBP, here are the 5 episodes we will have. The first one for today will be about the concept, why to use the optimizer, how does it globally works, what does it aims at doing. Second episode will be about the configuration for you guys, consultant like me, how to set it up and make it working. Episode 3 is more about the business sides, how to use it to operate the optimizer, and in particular the master data input, the cost input, and later the result. Part 4 will be about simulation and agility. How can you make use of this optimizer with regards of your supply chain challenge, and how is it agile and flexible to fit your business context. And last but not least, at the end, because several times I've heard the questions, shall you use the heuristics or the finite heuristics or the optimizer or time series or order based? This episode will all be about the capabilities of each individual options. Optimizer is a quite famous topic in the supply chain, and a lot of literature and document exists. I'll give you a couple of seconds here to read this standard definition. Hope you have time to read this out. And there is many other definitions of optimizations, which are all aligned, of course. Now let's go into a more pragmatic presentation of optimization. In a more common language, optimization is a bright way to use mathematics and algorithms to solve complex solutions. It is, as a second point here, it is a bright engine which can select out of millions of solutions the best one within an acceptable runtime of the jobs, of the optimization run job. Also, the optimization can fit many contexts, so it's not only supply chain. In our case, we will focus on supply chain, but it could be anything else. And last year in this list, the optimizer provides capabilities to calculate a finite plan, whereas the MRP logic, for instance, only provides infinite plan, which you need to manually resolve. Here, the optimizer, the optimization capabilities provide you a feasible plan as well, and optimize. What are the optimizer options? There is several kinds of optimizer that you can use in supply chain. So let's say what I call the scientific option is to call for external solutions which are coded, meaning the business rules are transformed into codes and programming language to calculate and feed the engine for the optimization. The second one is, I would say, the flexible and agile one. You make use of Excel solver, which is very limited to 200 variables, for instance, but of good value and no particular skills required to run it. But of course, it's not integrated with your ERP or APS. And the last one are current options provided by SAP. SAP does not open the optimizer coding aspect. It transforms your master data into variables in the systems, which calculates your plan, optimized, and returns results directly. So no need for programming skills, but you need to understand how it works. Here in these slides, I'm presenting the data flow during an optimization sessions. First, the data are extracted on the very left here in the slide. Then they are converted into variables before they are delivered into the optimizer server. The optimizer server runs, generates planning results here, and those planning results returns to your APS, get converted back into understandable elements in your APS, meaning orders if it's order-based planning, OBP, or in time series if it's time series in key figures, if it's time series planning that you are using. The main contribution of the APS on the very left here is to provide master data, MD here, transactional data, and the result, planning result here, are returned into transactional data and log on the left side. So that In process term, an optimization sessions is made of inputs, which are master data, cost, transactional data. Then the outputs, secondly, the outputs which are provided by the optimizer, and they are the supply plan, possibly the quota. Okay, these are the main outputs. Third, the other output, which are the log, optimization log, where you can understand, that's not so easy, you can understand why the optimizer has taken this decision or this decision. This is the optimizer log. Very important, particularly during the project phase where you want to fine-tune the optimizer to answer your customer business requirements. Okay. And the further option is also from the project perspective, the explanation tool. So these are the four elements of an optimization session. As mentioned before, an optimization session needs input, and part of those inputs are master data. They are organized here in the master data model. They are made of location, of transportation lane, of product, as you can see here in the blue box, of product, of resource, recipes, calendar, and so on. So the master data that you know even for heuristics, to the exception that here I've mentioned the quota, and they may be disregarded by the optimizer because the optimizer may calculate them, by the way. Okay? Otherwise, it's a pretty conventional master data model that is used by the optimizer. In addition to the master data model, there is the cost model. The cost model is specifically designed for the optimizer and by SAP, by the way. It is made of a numerous costs. Like you can see in the blue box, there is 19 types of costs which you can define in order to control the behavior of the optimizer while calculating the plan. It can be of cost and limits, for instance, maximum production resource limit. Okay, you don't want to exceed that much capacity for a resource. And the cost, like here, could be the transportation cost, variable fixed, the production cost, variable fixed, procurement cost, variable fixed, and so on and so forth, 19 types of them. Also very important in the optimizer and the cost model, there is some hard and soft constraints. The hard constraint, like production maximum capacity, cannot be exceeded by the optimizer. If there is no solution, so optimizer say stop and goes in error. Soft constraints are the one which the system will try not to violate, but if it does violate such constraint, it will include a penalty to that violations. For instance, the safety stock utilization violation constraint. Okay, and the limits I have mentioned already here, which are more or less the hard constraint. So this is the cost model. So far we have seen the master data model, we have seen the cost model, and now combining those two together, we will establish in fact the real supply chain model, which includes all the business rules that you want the systems to follow by means of cost and master data setup. For instance, you wish to have some supplier limits with a constraint supplier scenario. You wish to optimize your asset utilization, production asset utilization. You wish to include multi-sourcing. You wish, like it's shown in the blue box on the top here, you wish to prioritize your plan regarding or depending the customers, the seasonality anticipation, some push production, campaign planning. This is what I call the supply chain model, which is covered by means of cost definition, master data, and also the transactional which exists in your system. So far we have discussed about cost model, master data model. We've said that the system was using mathematics and so on. But by the way, what is exactly the logic of optimization when it is currently calculating? In fact, the system calculates a single solution at the beginning, which has a cost, multiplying all the production cost, transportation cost, whatever, and coming to a top and total cost here, as it is mentioned on this graph. And the idea of the optimizer is to engage the first calculation, then search another solution, which is also a feasible solution, which is with a lower cost. And that's the logic of the optimizer, to the objective functions being the total cost, to reduce this objective function to the minimum in a given short runtime. That is all about the logic of the optimization when it happens. I'm pretty sure you wish to see a little bit of the systems today, although it's not the main focus. Okay, let's go in SCM Labs to show you some elements of an optimization session. And for that presentation, let me use SCM Lab, which is the rapid deployment solution, pre-configured solution from Camelot, which covers all processes in IBP, including order-based planning and time series session. Let me use the good tactical supply planning inputs. I'm not going to discuss about cost for today, rule-based cost modeler from Camelot or the supply cost management, but I will directly use the optimizer overview. So here, we are at the start of the story. We have received a new demand plan, which do not fit anymore with what was calculated last week as a customer receipt. Therefore, here we have currently a, I would say, customer service level, which is not so good, sometimes exceeding even the demand, like here 600%. So, and if I go and give you an overview, we see that there is a lot of red lights here. Let me go to the heuristics quickly. So here we are, we have the heuristics results. Heuristics being an unconstrained and infinite solution, it will always cover what is requested from the forecast or even sales order as total receipt. Say you're going to get 242 because you need 242 as mentioned by the demand planner. Okay, and if I go again, zoom out, I see that it's mostly green. There is infinitely, yes, any demand is covered, but the consequence is in terms of capacity, that in fact we are in average overloaded by 207% for this particular production resource and even to 400 locally for one particular weeks. You see that is just not feasible. And we see that we have mostly one resource being used and heavily overloaded for the period. How do I do in standard to cover that? Using a heuristics, I would have to review the production by increasing the capabilities, the capacities, okay, so-called capacity supply, increasing each resource, okay, or coming to the production and in the production, playing with the adjusted production receipt on the different products in order to reshuffle when a product shall be produced and so on according to the capacity being available on the other end. Not an easy job. You can make even use of the capacity detail view. Here, where you see for this resource, currently 3 products are consuming this resource to this quantity level due to production order, production receipt order. It's not an easy job, and that's a typical heuristic scenario. Now, back to the initial situation where we have received the new demand plan. And by the way, now, instead of running the optimizer, we wish, running the heuristics, we wish to run, in fact, the optimizer. Let's go with that. So here it is. Now we have the optimizer results. We still see that, well, it's much better. Most of the customer demand and versus receipts is green, wherever it is possible, but sometimes it stays red or with different colors because maybe the optimizer could not cover all demand, not like it is done by the heuristics. But now let's see the counterpart, the capabilities or the production capabilities. And now here, see that was heuristics result. Now it has been converted to optimizer result. And now we see that in fact, not only that the production is not happening anymore on this resource, but better on this other resource because it was probably cheaper. There was some cost definition in there. Not only there, but also using another resource in another plant. So you see factory balancing, asset utilization has been maximized to reach a 100% level as much as possible. And if we go zoom out, we see that it's mostly green everywhere, meaning that apparently the optimizer has done a good job. That illustrates quickly, I admit, quickly the optimizer capabilities versus a standard heuristic scenario. Now, next topic is why should you be going optimization? There is many reasons for that. I have listed down here 6 reasons, out of which we have the MRP logic does not provide any feasible plan, neither the heuristics, which is by the way an MRP engine, okay? And also because the solution itself, in terms of user experience, application, and so on, is not so much helping understanding the heuristics result in order to take the appropriate actions easily. No way. It's by the detail, moving product, adjusting production order, transport order. This is a tough work to do. Okay, because we want a profitable plan, and by the way, heuristic is not so doing. So that would be a reason to go for optimizer, and also because you trust the system to provide you a plan. These are the options which would explain why you could go optimization. But there is also reason not to go optimization. And very frankly, if your organization does not include the necessary skills, you don't have the IT support, you have no subject matter expert, SME here, to cover these topics explicitly, because you only trust what you understand, and optimization results are not so easy to explain. That's a very good reason as well, because you have internally a good MRP2 logic process running, which provides feasible plan out of several weeks of work. But anyway, it fits your requirement. That's fine, because you invested so much in this current solution that you don't want to trash out everything just for the sake of having a nice mathematical engine running your plan, and so on and so forth. And also because implementing optimizer, it's nothing like a 2 weeks or 3 weeks sprint in a Scrum model to activate optimizer. No, technically probably, but company-wise, project-wise, it's an heavy project from 9 to 12 months, probably. Okay, and these are the reasons probably not to go optimization, and to be very clear. We are now finished with the optimizer presentation and the concepts. Next episode will be focusing on the configuration and the setup. We will see SNOP profiles, we will see key figures, we will see limits, key figures, scoping of the optimization session by means of subnetworks, and so on. Let's see that in the next episode. Thanks for watching, and don't forget, a like or a subscription in YouTube. It makes my days. Thank you, and see you soon.